disappointed? What if parents that were students?
Yeah,
Anybody. All right. Listen. Okay, enough about stuff that we cannot fix. We cannot fix right this second. So let's learn some math. Yay! All right. So just like with multiplying radicals, the only thing you need to have that is the same to divide is the same index. Okay? So you can only divide square root by square root. You can only divide fourth root by fourth root. If there's a mixture of the two, you cannot divide anymore. Okay? As always, I have a ton of steps to give to you. Once we get all the steps, we'll actually go through the problems. It'll make it a little bit easier. So, dividing radicals. The first step says, replace the small radical with one large. So, replace the small radicals with one large. I'm going to show you how to condense some of these steps so there's not so many. Okay. After you do that, we reduce the fraction. Under the radical. Okay. Everything always has to be in smallest terms. So keep thinking in your head, reduce, 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 okay? Then we're going to rewrite it with small radicals again. Okay, I'm going to tell you this. I don't ever rewrite mine with a large radical. I just reduce and keep them as small radicals. So while these steps are here and I'm giving you the steps, we're going to condense this and make it easier. Because I just think some of these steps are just way too much to think about. Okay. Then I need to simplify if possible. Reduce if possible. And then rationalize if necessary. So not all of these steps are going to be used each and every time.
Number 4.
Get all the steps down.
Teachers, at this time, please release any seniors you have. Please release all seniors. Thank you.
No.
I'm a senior.
No.
Senior.
I wish I was.
I'm with your senior area.
I'm singing to you.
I'm supposed to be a senior. I failed.
Listen, none of y'all are seniors. Y'all are stuck with me.
I'm half senior.
You're right, man.
Like I.
All right. All right. Does everybody have their steps down? Okay. I've got a couple still ready. Oh my gosh. He getting way too into this over here. Like, I don't know. Muhammad, you're getting way too into this today.
Like what happened yesterday?
Oh my gosh, you're so big.
Although he just moved.
Oh, Miss Smith in my
Yes,
4th
ma'am.
period.
Okay.
I thought she taught. Miss Smith. In
We
my
good?
4th period, we wrote an essay about dividing. Okay.
You wait, what?
Yeah. boy.
Say that again. What period you did what?
My 4th period.
You wrote an essay
My
Why?
about what?
women,
Oh,
influential women.
influential women. You talked about me?
Yeah.
Did you really?
Yeah. No. Yeah, I swear.
Can I read it?
I don't know if it's done yet. I talked to one of the females.
Okay. So basically what you want to do is you want to reduce the coefficients in the front if you can. Does 3/2 reduce down at all? No. So we're going to keep it. 3/2. Okay? It says that I should take those small radicals, and what it wants us to do, which I'm not going to, it wants us to take it, and instead of doing 2 small radicals, they want you to rewrite it so it looks like this.
Oh, that's smoking.
What's the point?
Oh my God.
That's stupid.
Okay? So we're not going to do it. So we're going to leave it as 2 radicals. But take a look at your radicals. The numbers underneath your radicals. Does 20/4 reduce?
Yes.
To what?
5.
5/1. So this actually becomes the square root of 5 over the square root of 1.
Wait, is this as easy? Is this supposed to be as easy as multiplying?
It is until you actually have to rationalize sometimes. Rationalizing can get a little bit difficult.
Oh, Michelle Rainbow, she's in my group. You should ask her about it. I think she's the one who did it.
Okay, so 3 square roots of 5. Can that be simplified? No. So we keep 3 square roots of 5. What is 2 square roots of 1? Just 2. The square root of 1 is 1, so this is just 2. Can it be reduced? No. Rationalizing means if I have a square root left in the bottom, I would have to rationalize. Is there a square root in the bottom? No. You're done.
Wow.
That is so.
Why is that easier than multiplying?
That's not easier. Don't say
I
that.
don't even know how to.
It is.
I thought multiplying was easier, and I got stuck on the homework.
Is it the binomials?
How is that?
Okay. We can look at that some more. I don't think you're going to see a lot of that.
So why do you?
But
It was like the
we'll
4th problem.
we'll look at it some more. Okay. We can look at it some more. That's not a problem. Okay. All right. The last one. Again, the coefficients first. 1/5. Can that be reduced?
No.
No. Okay. So I'm going to write the one just so you know that it's there. You do not have to write it. Okay. So now I need to reduce my radicands. 15/20 reduces down to 3/4. So I've got the square root of 3 over the square root of 4.
Wow.
1 square root of 3. Does that reduce?
No.
Or simplify? No. So I'm just going to write it as a square root of 3 now. Remember, you do not have to write that 1. It will not be written as an answer choice. It'll just be the square root of 3. And then in the bottom, I've got 5 square roots of 4. What's the square root of 4? 2. So this is actually 5 times 2, which, Jalecia, you said was? Oh, sorry, Kate. That was 10. My bad. I apologize, Kate. I thought. Okay. I just brought the 5 down. Okay. So 5 square roots of 4 is technically 5 times 2, because the square root of 4 is 2, which makes your bottom 10. Your last thing you have to ask yourself, do I have a square root left in the bottom?
No.
No. That's my answer. We're done.
That's amazing.
That's amazing.
Watch her get home and look at this like, huh?
Okay. Please glue this in on page 83.
I can't do
Because
this.
that's what happened with the homework last night. I thought it was all
You thought you were all good until you went home.
And then I went home and I was like, huh?
We will look at some more multiplying. If your biggest concern is the binomial times a binomial, you're good.
Yeah, I think that's what
Okay.
I messed up on.
So we put this on 83.
83. We are on 83, right?
Yes.
Yes, 83.
I must.
Well, then you've missed some pages there, friend.
He was not on 62.
I know. Okay. So, because everybody asks me why on earth do I have to do this? Okay, so I gave you a why sheet on rationalizing the denominator and why we do it. Okay, so in the days before calculators, oh yes, there were dinosaur days where you didn't have that lovely electronic machine that gives you all the answers.
Yes, I remember.
Okay. Mathematicians discovered that it was much easier to multiply by a radical than divide by a radical. Therefore, it became customary to always rewrite division of a radical as multiplication.
So this is giving us a little history.
Yes, a little history with it.
We are in math.
When we rationalize the denominator, whenever there is a radical in the denominator that will not simplify. So, if you have something in the bottom like the square root of 3 that you can't simplify, or the square root of 5, we must rationalize.
What is rationalize?
Okay. Rationalizing means getting rid of the radical.
And now we're in English.
Okay. How? We multiply both the numerator and denominator by a radical that will produce a rational number in the denominator.
What do we include the why, when, and how?
Can you wait till I'm done? Y'all are always trying to jump ahead. Give me a second.
You should be happy we're trying to jump in.
I'm sorry that you weren't here yesterday. That's not my concern right now. Okay. All right. So why we do this is because back in the day when we didn't have calculators, they were given a sheet like this. So if you had to divide by the square root of 1, you would divide by 1.00000. If you had to divide by the square root of 2, you divided by 1.4542 or 41421. Okay? They had this spreadsheet that they had to sit there and use these numbers to do division longhand. Right.
Right. How about
So, take some time, glue this why, what, and how sheet onto page 84.
Are we cutting this?
Okay? This one.
I have to write my paper.
Listen, this one I need you to cut out along those dotted lines. And the other one I need you to create your little book so we can do those.
Already.
Yeah, good on these.
Yeah,
mine.
Not special.
probably first few days? Can you turn it on?
What do you want me to say? Boo, Justin.
Yeah,
Yeah.
he isn't special.
Boo, Justin.
Or at
you're
least
not
say mo
special.
first.
Oh crap, bro. Your glue fell out. I didn't do it. I swear to God.
He broke your glue.
We need the jumbo.
That is true. They do sell those jumbo ones. I don't get any trick-or-treaters at my house. It's sad.
Do you leave the light on?
I live on a dead-end street off the dead-end street. Nobody comes out.
I mean, the kids like come up to my room and like walk away.
We've lived here for 3 years. I've always had the light on. My husband and I sit on the porch and eat all the candy because nobody comes.
Sounds
Well,
nice.
stop doing it and stop buying candy.
We might should get the eat the candy ourselves though.
Yeah, you should have just gave us candy today.
Wait, you ain't got no candy for us. You know James
Wow.
is Halloween, bro. Come on.
It's Halloween. Come on, that's Halloween.
Why you not answering us, Miss Smith?
Because y'all are getting a surprise on Friday, so you just need to hush your mouth. Huh?
I thought we were getting a test.
You know about that, so it's not a surprise. You have an open notes quiz on adding, subtracting, multiplying, dividing radicals.
Oh my God!
Was that our surprise?
No, I have a good surprise that you will all be happy about. Stop being lying.
You know what?
Mo,
Well, Brooke is now added to my board. We have 55 days till Christmas.
Yay! Okay, but why not wait for you? Why is it always Christmas?
Like, you walk into Walmart right now and you can buy a Christmas tree and some candy canes, and I'm like, can I eat turkey and get that first?
Right, especially.
I need to look like Jolly Old St. Nick before
Especially in Bath and Body Works. I went to Bath and Body Works in the mall yesterday.
Oh,
Yes, they have 2 buy 2 get 1 or buy 3 get 2.
Okay, guys, we need to finish this, please.
Sit down.
Yeah, we really do.
Uh-huh. Have a seat, please. We need to finish. Okay.
Oh, I've stabbed myself before.
No.
All right. So, remember, we don't want to change the value of what we're rationalizing. Okay? We don't want to change its value. So, what can I multiply by that doesn't change the value of something?
1.
1. So, we're going to multiply a fraction by 1, and it does not change its value. Okay? You should also know any expression divided by itself is equal to 1. If I take 2 divided by 2, it's 1. X divided by x is 1. So, to get rid of a radical in the denominator, we multiply the numerator and denominator by the radical in the denominator. Okay. As always, this makes no sense to you until we actually go through and do it. Okay. So, if you will kindly glue this to the top of page 85, make sure you leave room to glue our booklet in at the bottom. Okay. Don't forget about our mini book.
Oh yeah, I'll be bringing in. Never mind, I can do it now.
What?
$1 something.
I don't have one, but I'm not dressing up.
My little sister got one, but I didn't. My mama made me mad with that. No?
I really don't want to get
What? No, like, it was smart. No, it was smart.
All right. So we need, our basic goal is to get rid of the square root of 3 in the first one. Okay, that is our goal. We want to get rid of that radical that's in the bottom. So, first things first, can this be reduced at all? 2 over the square root of 3? No. Okay, 2 over 1 is already reduced. Okay, we can't simplify the square root of 3. So, now, to get rid of that square root of 3, I need to multiply by the square root of 3 over the square root of 3. Okay. Because when I make a fraction that's the square root of 3 over the square root of 3, its value is actually 1, right?
Yes.
2 over 2 is 1, so the square root of 3 over the square root of 3 is 1. So I'm not actually changing the value. So watch what happens here. When I multiply, I should multiply straight across the top of a fraction, so that becomes 2 square roots of 3. In the bottom of the fraction, I've got square root of 3 and square root of 3, which technically becomes the square root of 9. Remember, you keep your square root and you multiply the radicands. Well, what's the value of the square root of 9? 3. So now you've gotten rid of that square root of 9. You've gotten rid of the square root in the bottom, and it becomes an actual value. Check again and make sure you don't need to simplify. Does 2 over 3 reduce?
No.
No. You're done.
I'll be home.
The other one we have 1 over 5.
Okay. So, Jalecia just looked at the next one. The square root of 2 over the square root of 10. This technically becomes the square root of 1 over the square root of 5. 2/10 reduces. Okay. What's the square root of 1? 1. So this is technically 1 over the square root of 5. Now I need to rationalize. I need to get rid of that square root. So what's the fraction that I'm going to multiply by this time?
Square root of 5 over square root of 5.
Square root of 5 over the square root of 5. You always multiply by the radical that is in the denominator. So this now becomes the square root of 5 over square root of 25.
Witnessing a pattern.
And that is 5. Are you noticing a pattern?
Yes.
Look, when I rationalize the bottom, it just becomes the radicand that you originally had.
Will it always be like that? Or
The only time it's not going to be like that is if there was a number out front of the square root. So what I mean by that is if I had, I don't know if there's one in here. Let me check. Oh, yeah, we'll get to that. Okay. I'll show you where that doesn't work. Yes, ma'am.
can you like say what you did as you go? Like you did this time, but
Okay.
can you do it again on this problem?
The one on the left,
The one on the right.
the one on the right. Okay. So we reduce this first. 2 over 10 becomes 1 over 5. You're good there. Okay. Square root of 1, its value is just 1. Okay. So then to get rid of the radical in the bottom, you have to multiply both the top and the bottom by that radical. Okay. So 1 times the square root of 5 just becomes the square root of 5. Square root of 5 times the square root of 5 becomes the square root of 25 because 5 times 5 is 25. Oh, because you weren't here for the multiplying, so you were trying to figure out where the 25 and everything came from.
Yeah.
Okay, you're good. Okay. So when you multiply radicals, you have to have the same index. So it has to be like square root, and you multiply what's underneath of it to get your number that goes back underneath of it. Okay. All right. Flip your page. Square root of 2 over the square root of 6. Square root of 1 over the square root of 3. 2, 6 reduces down to 1 over 3. Okay, so this becomes 1 over the square root of 3. No, you were right. We multiply by the square root of 3 over the square root of 3 to rationalize. I need to get rid of that square root of 3 in the bottom. Okay, so this becomes 1 times the square root of 3, which is the square root of 3, over the square root of 9. And the square root of 9 is a perfect square, so it becomes 3.
Can we not just say that's 1? And it's like 3 and 3 over each other? That's the square root. Oh, never mind.
Yeah, the square root of 3 is not 3, so just be careful with that.
Oh,
Okay.
So we got,
Look at your next one. Oh,
I'm not doing that
I got, it's not that bad. Can I reduce?
one. No.
No. Okay, so I need to multiply by the radical in the bottom. So I'm going to multiply by the square root of 2 over the square root of 2. Okay, just the radical. Don't worry about anything else. So in the top, when I multiply, remember we multiply coefficients first. So 4 times 1 gives me 4. square root of 3 times 2, which is 6. In the bottom now, 3 times 1 is 3. Square root of 2 times the square root of 2 is the square root of 4. Remember, the square root of 4 is what? 2. So this is technically 4 square roots of 6 over 3 times 2, which is 6. So this is 4 square roots of 6 over 6. Last thing, can I simplify this one?
No.
Yes.
How?
What simplifies here?
2. Oh,
4 over 6 will reduce down to
2 or 3.
2 over 3. So your final answer is 2 square roots of 6 over 3. Okay.
What if it, on the test, right? They have
They're
both
gonna
of those answers on the bottom. Which
they're going to have the reduced answer.
okay. They're not gonna have
Okay.
the other one.
If for some reason, and they should not, because technically both answers are correct, but if for some reason they would have both, always choose the reduced one.
Or we come and let you know.
Okay. They are trying to trick you if they do that. I've never ever seen them do that, but again, you never know. Life is unpredictable. You simplify, remember, when we simplify, you have to simplify the coefficients, and then you would simplify the radicals. Well, we don't have a radical to simplify that with. Okay. All right. Flip it. Oh, man. Here we go. Okay. Does this reduce at all before we start?
yes.
Yeah.
Okay. Does 2/5 reduce? No. So that stays. But 15 over 10 reduces down to 3 over 2. So this is the square root of 3 over the square root of 2. Okay. That's where we can start. Okay. I need to get rid of the radical in the bottom. So what am I multiplying by? Square root of 2 over the square root of 2. I know I'm going into the next page. That's okay. Okay. So we're going to multiply by the square root of 2 over the square root of 2. So in the top, again, coefficients first. 2 times 1 is 2. Square root of 3 times the square root of 2 is square root of 6. In the bottom, 5 times 1.
5.
And square root of 2 times square root of 2 is square root of 4. So this is technically 2 square roots of 6 divided by 5 times 2. The square root of 4 is 2. So this is 2 square roots of 6 over 10.
Can we not reduce 2 over 10?
2 over 10 reduces to
1 over 5.
1 over 5. So this is technically square root of 6, because remember, I don't have to write the coefficient of 1 over 5. Okay, this is why we reduce first, because then it's not so much reducing at the end. If we didn't reduce first, we could have multiplied by the square root of 10 over the square root of 10. But you would have had so much to reduce at the end, y'all would have been pulling hair out. Okay, so reduce first, then do your steps, and then reduce at the end if you need to. Okay, there is a method to my madness.
16 has a perfect square.
Give me 1 second here, friend. We will get it. Okay. Right. Okay. So, can this reduce?
Yes.
Yes. 3/5 doesn't change. 16 over 12 becomes 4 over 3. So the square root of 4 over the square root of 3. All right. So, Muhammad's already noticed, and he went way ahead of my game. Okay. 16 was a perfect square. Well, when I reduced it, I still have a perfect square. What's the square root of 4? 2. So this is technically 3 times 2 divided by 5 square roots of 3. So I have 6 over 5 square roots of 3.
So it would be times the square root of 3.
Beautiful, Mel. So 6 over 5 doesn't reduce. So I need to rationalize those. So I've got square root of 3 over the square root of 3. So when I multiply here, that's 6 times the square root of 3. And 5 times 1 is 5. Square root of 3 and square root of 3 is square root of 9. So technically that's 5 times 3. Excellent. And that's 15. So 6 square roots of 3 over 15.
Wait a second.
Go ahead. Talk me through it.
Then you, nope.
Yeah, you can simplify.
You can simplify by 3.
6 over 15 reduces by 3.
2 over 5.
So 2 over 5.